let's begin from this one. This is a word problem that was nice like the other one on the last presentation I gave. On this one, we have a problem that the weight of juice in a bottle is normally distributed with a mean of 64.27 ounces and a standard deviation of 0.12 ounces. If a bottle is randomly selected, find the probability that the juice weight is more than 64.20 ounces. Your first step is to write all your information. The mean, which is 64.27, the standard deviation, which is 0.12, and your probability section, which is the probability that is greater than or equal to 64.20. Now, when we do that, we have to make sure that it's normally distributed. And we have the mean and the standard deviation. Okay, now we're going to have the probability. The probability is that it's greater than 64.20. So 64.20 is right there. We have to take the z-score that goes with that 64.20. That's where you use that z equals 2x minus the mean divided by the standard of deviation. So that's going to be the formula you use. You're going to have 64.20 minus 64.27 divided by 0.12, and it gives you your negative 0.58. Once you do that, you rewrite that probability. Instead of its probability of greater than 64.20, it's now going to be probability that z is greater than 0.58. So now we're going to have this, and we're going to go ahead and find that probability on the tables. Now, the only problem is that you can't get them from the right side. So you have to get them from the left side and then subtract from 1. So we're going to do that. We're going to go on to negative 0.58, and we're going to find the left side of it. That's 0.2810 right here. We subtracted from 1 to get the blue area. So we get 0.7190. So that means that the probability of finding juice that weighs more than 64.20 is going to be about 71.9%. And that's our answer for that one. Let's look at the B part. If a bottle is randomly selected, find the probability that the juice weight is between... Now, before we do that, let me go back and say something else. You could have done this problem, okay, using the calculator. Now, let's look and see here. Okay, the calculator is on this desktop. Let me pull it up. Okay, so now I'm going to move all of this since we already found that. Okay, so now what we have is this. Okay, we look at our calculator, and what we can do is say second inverse, go out to normal CDF, find from negative, now notice this is from 64.20 all the way out. So that's from negative 0.58, because you have your z-score, all the way out to infinity. So we just put a big number there, and we enter, and we get the same answer. Okay? So we get the same answer either way. So that's going to be our answer right there. Now let's go ahead. Now there's another thing you could do, but I would warn you against it because of the final exam. But that's second verse, normal CDF. You could go from 64.20, comma, all the way out to infinity. Then you would put your mean, which is, our mean was what? Our mean was 64.27. And then our standard deviation, which was 0.12. It might be a little bit off because basic was a lot off, and that's why I was wanting to warn you about it. It's not wrong. It's basically what's happening here is that the calculator does not round ever. So you're looking at rounding errors between the differences. Okay. So basically, I would suggest to go and do it in the z-score, through the z-score. let's go ahead and look at the next one. If a bottle is randomly selected, find the probability. Okay, so now what we're going to do is this. We're going to, first of all, we have between 64.10 and 64.40. Okay, that's our probability. We want this. Now, what we're going to do is find this probability for this one on the tables, and then we're going to find this probability on the tables, and then we're going to subtract the two. And that's how we will do it. Okay, now we have to find the z-score that goes for 64.40. So basically, we do that by the formula. Okay, now we're going to do this one first. So 64.10 minus 64.27 divided by 0.12 gives you negative 1.42. So that's the z-score for that one. Then we're going to find the z-score for this one. So we take in 64. And we find the area. I guess you're going to find the area now. You use the tables and you find this area. Now you're going to find the z-score here, 64.40. We have 64.40 minus 64.27 divided by 0.12, and you get 1.8 right there. And you find that area. Go to the tables and find that area on the left side. Now what we're going to do is to take the big area minus the small area, and that gives us the area in blue. So we subtract the 2, and we get 78.7821, or 78.21%, which is your answer. Okay, now that we've reviewed how to do the problems, we're going to go backwards, okay? And that's what the inverse norm is all about. Okay, so now to do the inverse norm, our first step is going to be to look at this right here. Let's draw our curves right here and see. Now for this one, which one of those do you think the z-value corresponds to? 87.08% of the data value is to the left. Well, if your area is to the left, you're going to have which one? Obviously, this one right there. Okay, so now we're going to use our, we're going to find the z-score that goes with that. There's two ways of doing it. You could go inside of the table somewhere, find the closest thing to 0.8708, and find the z-score that corresponds with that, which gives you the answer. Now, sometimes you're not able to do it this way. What you have to do is get the closest thing to it. Now, the other way of doing it is through the calculator. We can go ahead and clear this out. We can go second in vars. Okay, we can go all the way out to inverse norm and type in 0.8708 and then type enter. And you get your same answer, 1.13. Okay, the next way of doing it is this way. Let's try these. Correct? And correct. Okay, let's look at the next example. Let's find the standard normal z-value that has 75% of the data values to the left this time. Okay, now here's the problem here. Just like the other ones. Well, this one was exact. But on this one, well, first of all, let's look at this. Which one is to the left? Obviously, that's not to the left, and that's not to the left, so it has to be one of these two. 75% is more than 50%, right? So it really can't be this one. So it has to be this one right here. So that becomes your answer. Okay, so let's look at the next thing. The next one, so we have this right here. That's your 0.75. What you're going to do is find the inverse norm. Well, how do you find that inverse norm? How do you find that z-value? Well, go to the tables and find the closest thing to 0.75. Now, if you look, the closest thing to 0.75 is between 0.7486 and 0.7517. Now, what you want to do is find the closest one of those. Now, 0.7486 is about 14/10,000ths of a point away from 0.75. And the other one, 0.7517, is about 17/10,000ths. So this one is closer. So we're going to use that one right there. Okay, so now we're going to use this number, and we're going to find the z-score that goes with that number, which is 0.67. Okay, and that's the z-score that goes with it. Now, the other way to do this would have been to go ahead and use the calculator, go to second inverse, go to inverse norm, go to 0.75, and press enter. And just round it out to the hundreds, and it'll give you 0.67. Okay, now find these two. Correct. Okay, so now we're going to go to the next example. Okay, our next example. Let's find the standard normal z-value that goes the 85% of the beta values to the right. Okay, it's obviously one of these two because it's 85% on this side. So it's not this one or this one. So this is not greater than 50%. So the only one that's left is this one. Okay, so now our next step is to find this is our area, target area, but we can't find that with our tables. So we have to find the area on the left side. So we take and subtract it from 1. 1 minus 0.85 gives you 0.15. We go to the tables and find the closest thing to 0.15. Okay, so that gives us, the closest thing is going to be 0.1492. And we find the z-score that goes with that 0.1492. Okay, and that becomes negative 1.04. Okay, so let's go ahead and look at this right here. We have second inverse, inverse norm, 0.15, and enter. It gives you the same thing if you round it out to the hundreds. Okay, and that's how you do that one. Okay. Now, my computer's going haywire. Okay, here we go now again. Let's go ahead and talk about this then. Okay, so now there's where we go. Now let's try these. That's your numbers for that one. Okay, now that we have that, our inverse norm problems, what we're going to do is this. Basically what you're going to do is you're going to draw a curve and you're going to find where the area is for that curve. Now you go to the tables and find the z-score that goes with that table. Now you could use the calculator for this. Now let's look at this. Find a standard score that corresponds to 80% of the area to the left of the given standard score. Okay, so we go to our tables. We go to the closest thing to 0.80. That's 0.7995. That's going to be a 0.8 and then 0.04. So that's going to be 0.84, and that's your answer for that z-value. What about this one? 5% to the right. Find the 95th percentile. 95th percentile is 95% of this area right there. So what we want to do is take the second inverse norm of 0.95. Or we could go to the tables and get the same thing. How about this one? This one is between the two, right here. So what we do is say second inverse norm 0.025, or go to the tables. You're going to get negative 1.96. Because this normal distribution is perfectly symmetrical, then that's also going to be 1.96 right there. And that's going to be your answer. When you're doing word problems, here's the way that you do it. You're going to find a z-score that goes with that area. After you find a z-score, what you're going to do is you're going to use a formula. The formula is this one right here. X is equal to the mean plus z times standard of deviation. Then after you find that x, you're going to go ahead and answer the question based on that x. Okay, let's look at this right here. Now this one, okay. Now, let's look at this one right here. We have this number right there. Basically, I was showing this so that you would know what I'm talking about when we go ahead and do this one. In this distribution, the mean is 172, and the standard deviation is standard deviation is 29 and the mean is 172. We want to determine the weights to separate the lightest 99.5% from the heaviest 5%. Okay, so we have this right here is our drawing. Now what we're going to do is we're going to go to the tables and we're going to find the z-score that goes with that. We could also go ahead and do the calculator, which would become second vars inverse norm 0.9950, and that would become 2.575 right there. Okay, now that we have that 2.575, we use this formula. The mean is 172 and the standard deviation was 29, and then we calculate our value, and that gives us our answer. Okay, let's look at this one right here. The 15%, we've done A and B, we're going to do C. Okay, so now 15% of all juices in the bottles are above what weight? Okay, so now we have our mean, which was 64.27. Our standard deviation was 0.12. We want to find the X value that goes with that. So what we have to do is find what 15% is talking about. So the area that 15% is going to be where? Is this right here. We can't find that in the z-score. We have to find this area on the left side. So 1 minus 0.15 is going to give you 0.85. Now we're going to go ahead and find through the tables or the calculator what the z-score corresponds with 0.85. And that's 1.04. Now that we have a z-score of 1.04, we're going to use the formula. X is equal to the mean plus the standard deviation times the z-score. Okay, one moment. Okay, so we use this formula and we find the number 64.3948. And that's our value. Okay, so that's our answer for that one. Now, again, this is something you have in your book, and just look at it in your book, and it just gives you basically how to do the problems. And that's the end of this recording right now. Thank you very much.